Hello everyone, I have prepared some review questions for you for our upcoming test. This is not comprehensive of everything, but just some highlights and some interesting questions that I thought would be good for us to do together. Please make sure that you're going through your notebook. Go all the way back through. Make sure you focus on some of the more recent topics, but also make sure that you are really solid on your derivative rules and all of the other fundamentals that we've learned this year. All right, so let's get started with this first question. The graph of a twice differentiable function f is shown in the figure above. Which of the following is true? So this is the graph of f of x. Okay, so if I look at my choices, notice what they're all talking about. They are all asking me to compare f prime of -1, f prime of 1, and f prime of 0. Okay, so let's think about this for a second. If they're asking me to talk about f prime when I'm given f, we have to understand the fundamental concept that f prime is the slope of f. Okay, so we have to keep that in our mind as we're answering these questions. Okay, so let's just look at each of these values, f prime of -1, f prime of 1, and f prime of 0. So what is, if I'm asking for f prime of -1, I'm looking at the graph here of f, and at this graph, what is the slope of this graph at -1? Well, what do we notice at -1? We notice that we are at a relative min. And when we're at a relative min, we have a horizontal tangent. And so we would say that the slope at -1 here would be 0. Okay, what is the slope at 1? So go back to your graph, and what is the slope at 1? So if I look at 1, okay, what's happening in the graph at 1? Would I say that my graph is increasing, decreasing, or is a horizontal tangent? And I would definitely say that at 1, my graph is decreasing. Therefore, I don't know what the slope is, but I can be sure that the slope is negative. And the last one they asked me to look at is f prime of 0. Okay, so at 0, what can I say? Well, at 0, here's my graph, and the graph of f at 0 is definitely increasing. So I would be able to say that my slope is positive. Okay, so then our 5 choices ask us to rank these values in terms of smallest to largest. So obviously it would be our negative would be our first, and then our 0 would be second, and then our positive number would be third. And so that would be f prime of 1, and then f prime of -1, and then f prime of 0. So choice D is the correct sequence for those slopes. Okay, our second example here. Again, we're taking a graph and using it within our problem to help interpret and find our answers. So this time we're given the graph of y equals g of x, and let's just read it. It says the figure above shows the graph of the function g and the line tangent to the graph of g at x equals -1. Let h be the function given by h of x equals e to the x times g of x. What is the value of h prime of -1? Okay, so we definitely have to do the derivative. So before I even get into worrying about that graph, I'm going to go ahead and do the derivative of h prime of h of x. So h prime of x is equal to, clearly that's a product, so I'm going to do first times the derivative of g of x would be g prime of x, plus the second is just g of x, times the derivative of e of x is still e of x. Okay, now I'm going to go ahead and we need to evaluate that at -1. So e of -1, or 1 over e, times g prime of -1 plus g of -1 times e of -1. All right, so e of -1, there's nothing more I need to do with that, okay? But what is this g prime of -1 and g of -1? Well, g of -1 should be easy, okay? They're just asking me what is the value. This, remember, is the graph of g. So what is the y value? What's the output when the input is -1? And you can see that that would be a 3. So this is going to be 3 times e to the -1. Okay, now what about this g prime of -1? Well, I'm not given the graph of g prime, I'm given the graph of g. But what I know is g prime is, again, the slope. So we're talking about the slope of the graph at -1. Slope is the same as the derivative or the slope of the tangent line. And so here I have the tangent line drawn in. I'm told right here that the line tangent to the graph of g at x equals 1 is drawn. So if I could find the slope of that tangent line, that would be g prime of negative 1. How can I find the slope of a line? I need 2 points. Well, look at that. They give me 2 points, so I can find the slope by just doing the change in y over the change in x, so negative 3 minus 3 over 0 minus negative 1. So my slope here is negative 6. Oops, that was 0 minus negative 1. So my slope here is negative 6 over 1, or obviously negative 6. So I have a slope of negative 6. Okay, now I'm just going to go ahead and finish this off. Remember that e to the negative 1 is 1 over e, so this would be negative 6 over e plus 3 over e, which of course I could combine because those are a common denominator, and so I end up with negative 3 over e. Choice B. Okay, let's move on to the next one. Okay, in our third example here, it says for the function f prime of x is equal to 2x plus 1, and f of 1 is 4. What is the approximation for f of 1.2 found by using the line tangent to the graph of f at x equals 1? So this is that local linear approximation that we did, okay? And if you remember, what we need to do is take the equation that we have for slope, okay, for f prime, and take the given point that we have, f of 1 is 4, and we need to write the equation of a tangent line at x equals 1. Then from that, we can use that to approximate the value of f of 1.2. And so we can go ahead and the two things that we need would be our point, which as we said, they gave us f of 1 is 4 is the point 1 comma 4, and we need our slope at x equals 1. So f prime of 1 is simply 2 plus 1, so 3. So we have our slope and we have our point. Our equation of our tangent line is just going to be y minus 4 equals 3x minus 1. And then all we're doing now for the approximation, we're just going to go ahead and plug in the 1.2 in for x. So y minus 4 is equal to 3 times 1.2 minus 1. So that would be y minus 4 is equal to, let's see, that's 0.2. 3 times 0.2 is 0.6. Add over 4, so y is equal to 4.6. So our approximation here is choice D, 4.6. Now, if you remember, this obviously is multiple choice, and that's all you had to do. But then we had to ask ourselves, we talked about if that was going to be an over or an under approximation. So I want you to think about what it was that we needed to determine to see if that was an over or an under approximation. And hopefully you're remembering that we had to talk about its concavity. We had to determine if it was concave up or concave down at that value. So I'm going to just kind of keep going with this problem as if it was asking about that, just to kind of review this as well. So if I wanted to determine if this function was concave up or concave down at x equals 1, I would need the second derivative. Okay, so this is super easy second derivative. It is just going to be 2. So if I want to evaluate f double prime at 1, it's just still 2. So clearly that is greater than 0, and so we're talking about a concave up function. Okay, now if I think about the tangent line, the slope line, 2x plus 1 being sketched in there, okay, so if I sketch in a tangent line, you can see that any point on that tangent line is going to be below the curve. Therefore, the value that we got, the 4.6, is an under approximation. And so what we can conclude is that f of 1.2 would then be larger than 4.6. Because 4.6 is an under approximation, therefore the actual value on the yellow curve here is going to be larger than 4.6. Okay, so that was just, like I said, I took that a little bit further than the question was asking, but I thought it was a good review of everything that we had learned during that class. Okay, and this next question, very common question on the AP exam. You're given the graph of f prime and you're asked to answer the following question. So usually in a multiple choice question you would just be focusing in on one of these, but I'm going to go ahead and use this graph to kind of review and go through all of them. So we are given the graph of f prime. Remember, okay, you might want to make yourself a note of that. And as soon as you're given the graph of f prime, look at what you're being asked. Part A and Part B are being asked about when the function is increasing and relative mins or relative maxes. If you're asked anything like that, then you need a sign chart for f prime. So I'm going to go ahead and make myself a sign chart for f prime right off of the f prime graph. So what does that mean? Well, I need any zeros of f prime. Now remember, I'm using the actual graph. Zeros of f prime are when f prime crosses through the x-axis. So that happens at 2, 4, and 6. I would say those are my zeros. Okay, then I need to determine when is the graph of f prime positive and when is it negative. So I'm going to go ahead and recognize that between 0 and 2, so I actually have closed intervals here, 0 to 7. Okay, so between 0 and 2, I can definitely say that I am below the x-axis, so negative. Okay, between 2 and 4, I have shot up above the x-axis, so positive. Between 4 and 6, I'm again below. And between 6 and 7, I'm again above. So remember, if f prime is negative, that means that my function is decreasing there. Positive means it's increasing, decreasing, and then increasing. Okay, once I have that sign chart, I'm able to answer questions A and B very easily. So question A just says, over what interval is f increasing? Well, like I said, just go ahead and look at the sign chart you just made, and you can see that it's increasing. So f is increasing from 2 to 4 and from 6 to 7. And that would be because f prime is greater than 0. All right, part B says, state the x value or values when f will have a relative minimum. Okay, well, when's it going to have a relative minimum? It has a relative minimum when we go from decreasing to increasing, when we make that switch. Well, you can see that happens here, and it's going to happen again here. And so we have two different x values, and so we would say we have a relative min at x equals 2 and at x equals 6, and that's because f prime changes from negative to positive. Okay, the next question, letter C, says, over what intervals will f be concave up? And hopefully you're saying, wait, concavity, oh, that I need my second derivative. So I need to make a new sign chart using my first derivative graph, but I need to make a sign chart for the second derivative. Okay, so let's see if I can kind of squeeze it in here. All right, so I'm going to do it here. Okay, so remember, the second derivative is the derivative of the first derivative. And so what does that mean? I need to think about the slopes of f prime. And so when I'm talking about my zeros, I'm talking about when we have any horizontal tangents or if we have any kinks. Okay, so if you look here, I would say that the slope is 0 at 1, at 3. I would say that I have a kink here at 5. Okay, it comes to a point, so it's undefined there. And that's it. Okay, so those are my zeros or my undefined. That's when my slope of f prime is either 0 or undefined. Now I have to fill in and determine if I have positive or negative slope. Well, we should hopefully know if we are going downhill like you are right here. If you are decreasing, okay, then if f prime is decreasing, that means its slope is negative there. So that would mean between 0 and 1, I had a negative second derivative, which means I would be concave down there. Between 1 and 3, okay, well, what's happening in the graph between 1 and 3? Well, here you can see, hopefully, that the graph is going uphill, and so therefore the slope of the first derivative is positive. So the second derivative is positive between 1 and 3, telling me I'm concave up. Okay, between 3 and 5, what's happening? Well, the whole time between 3 and 5, what's happening? The graph is going downhill, so that would be a negative, and so I'm going concave down. And then between 5 and 7, I would again say that I'm increasing, so positive, concave up. And so letter C just asks, over what interval will it be concave up? So if I squeeze the answer in here, I would say that it's concave up between 1 and 3 and from 5 to 7 because the second derivative is greater than 0. Okay, so hopefully that was a good review for you. If not, go back over those questions, questions like number 4, where you're given the graph. The biggest thing that I can stress is if you are given the graph of f prime, if you're given the graph of velocity, for example, and they ask you some questions about it, please make sure that you are making a sign chart in order to inform your answers. All right, let's move on to the next one. Okay, let's take a look at number 5. It says, for x is greater than 0, f is a function such that f prime of x is equal to natural log of x divided by x, and f double prime of x is equal to 1 minus natural log of x over x squared. Which of the following is true? Okay, now if you look at your 5 choices, the first half of all of the choices are talking about when the function f is either increasing or decreasing. And the second part of all the choices are talking about when the graph of f is either concave up or concave down. So all of them are asking us information about the original function, and we were given the first and the second derivative. So that's kind of nice that we're given the first and second derivative. We don't have to calculate those, but we have to be able to use them to inform our decisions about the original function. How do we do that? Well, hopefully you're saying we need to make sign charts for the first and the second derivative. The sign chart for the first derivative will tell us about when the function is increasing or decreasing, and the sign chart for the second derivative is going to tell us about when the function is concave up or concave down. All right, so let's start with the first derivative. So f prime of x, we're told, is natural log of x over x. All right, what do I need for my sign chart? I need critical values. We're told that our sign chart, we're told that x has to be greater than 0. Okay, so we're going to start at 0 and move to the right, f prime and f. Okay, now critical values. Critical values are when we get zeros or undefined. Well, you can tell we're going to get the undefined when x is equal to 0. And so that one we don't need to worry about because we start at bigger than 0. But when does it equal, when does the function, when does natural log of x over x equal 0? Well, I would set my numerator equal to 0, so natural log of x equals 0. Natural log of what number equals 0? Hopefully you remember that's 1. Natural log of 1 is 0. So I'm going to go ahead and put 1 on my sign chart as a 0. All right, now I have to test values into the first derivative between 0 and 1 and larger than 1. So I'm just going to first of all start with like 0.5. So if I asked you what's the natural log of 0.5 or 1/2? Well, remember we talked about in class that if I am trying to evaluate natural log of 1/2, what is that really asking? Well, what that's really asking is you to think about the exponent you'd put on a base of e to give you back 1/2. Remember, natural logs are always solving for exponents. So what kind of exponent would you have to put on a number bigger than 1? E is 2.7 something. Okay, what kind of exponent would you have to put on that in order to get back a fraction? Hopefully you're telling me, oh, I would need a negative exponent. And in fact, you would. So natural log of 1/2 is going to be a negative number divided by a positive is a negative value. And so f would be decreasing between 0 and 1. Okay, now pick a number bigger than 1. So if I picked the number, say 5, all right, natural log of 5. Well, natural log of 5 is going to be positive. It's going to be a positive number, and so we would say that positive divided by positive is going to be positive, and so it would be increasing there. Okay, so right away I know that f is going to be increasing when x is greater than 1. And so right away I can cross off choice A and choice E. All right, so now I'm talking about its concavity, which is the second derivative. Okay, so let's take a look at my second derivative, which is 1 minus natural log of x over x squared. Okay, so same thing, I need to set up my sign chart, and same thing, it's going to be from 0 on. Okay, so again, I have to say when does the numerator equal 0. So 1 minus natural log of x equals 0 when natural log of x equals 1. So natural log of what number is equal to 1? That would be e. And so I need to put an e on my graph here as the 0. All right, so now I need to determine, okay, when I'm to the left or to the right, is it going to be positive or negative? Well, you notice the denominator is x squared, so that's not going to change anything, okay? So between 0 and e, 1 minus natural log of any number between 0 and e. Well, any number between 0 and e, so if I said 1, okay, 1 minus natural log of 1, well, we just said natural log of 1 is 0. 1 minus 0 is 1 divided by a positive, so that's going to be a positive. So we're going to be concave up there. Okay, a number bigger than e, so 5, 1 minus natural log of 5. So natural log of 5 is going to be a number bigger than 1. And I know that because I'd have to raise e to a number bigger than 1 in order to get back 5. And so I would go ahead and say 1 minus a number bigger than 1 is going to be negative. So this is going to be negative or concave down. Okay, so you got to kind of think through those exponent rules and think through your natural log graph. The other thing that would help with these is if you kind of have the natural log graph memorized. If you know that the natural log graph looks like this, and it crosses through the x-axis at the point 1, 0, then you can see right now that natural log of all of these decimals were in fact negative, and any number bigger than 1 is positive. So having the natural log, the y equals ln x graph kind of memorized would also help you with the signs for these sign charts. Okay, so once we have this second derivative sign chart done, I can finish up this question. Okay, taking a look at my choices, I determined that f was increasing for x. Oh, I should have crossed this one off as well. Sorry about that. F is increasing for x is greater than 1. And now they're talking about whether it's concave up or down when x is greater than e. So when x is greater than e over here, I was definitely concave down. And so that would be choice C, would be our answer for this question. Okay, last question that we're going to do today. A particle moves along the x-axis and its position is given by the function x of t equals 4/3 t cubed minus 8t squared minus 5t plus 1. When t equals 1 second, is the particle speeding up or slowing down? Okay, so I just want to quickly, before we jump into this question, if we are talking about a particle and we're talking about its movement left or right or when it's at rest, what is that we are trying to evaluate for the given function? Hopefully you are telling me velocity. Okay, so if you're ever asked any questions and you're talking about its movement, when is it moving to the left or to the right, we're talking about the velocity function, not the position function. So we'd have to take the derivative of the position function to get to the velocity. If we're asked a question like this, talking about when it's speeding up or slowing down, well, there's two things you can think about. First of all, if you're asked when it's speeding up or slowing down, we have to know that we are looking at the signs for both the velocity and the acceleration function. If at the time given the signs are both the same, then we hopefully know that the function is speeding up. If the signs are different, one positive, one negative, then we know that the function or the particle is slowing down. So if they ask for the interval, then we need to do a sign chart for both, which is more work, right? You have to get the critical values for velocity, critical values for acceleration. Then you have to do a sign chart for both and see where they overlap to both be positive or both be negative or one of each. Okay? However, when they give you a question like this, don't waste your time doing all that. They are giving you a specific time to focus on. So we do definitely need to get the velocity and the acceleration function, but then you just need to evaluate it at the given time. So I'm going to go ahead and determine the velocity function, which of course is the derivative of x of t. So let's see here. 4/3 times 3 is just going to be 4t squared minus 16t minus 5. Okay, I'll go on and continue on and find my acceleration function as well. So a of t, that's the derivative of velocity. So that's going to be 8t minus 16. All right, now what I need to do is evaluate each of those at t equals 1. So v of 1 is what? Well, that's 4 minus 16 minus 5 is definitely less than 0, definitely negative. Okay, a of 1 is going to be 8 minus 16, which is also going to be less than 0. Okay, so if I have both velocity and acceleration negative values at a time of 1, then I can definitely conclude that at t equals 1, particle is speeding up. And you would conclude that because v of 1 is less than 0 and a of 1 is less than 0. All right, good job. Like I said before, this does not at all, in any way, shape, or form, cover everything that's going to be on the test. You should know these topics as well as everything else that's in your notes. As I've said, one of the best things you can do is go back through test number 5, and that in conjunction, or test 4, test 3, any of the old tests, that in addition to looking at the recent in-class practice problems would really help you get ready for this test. All right, thanks so much. Study hard, and I will see you in class next time.